Hi, welcome to this video where we are going to be focusing on how to evaluate algebraic expressions given the replacement values of the variable. And what that means, y'all, is that we're actually going to be looking today at algebraic expressions, which will now have letters involved, variables, and we're going to actually be replacing the variable with a valued number. So let's get going here with our two different types of expressions. In our previous video, we had talked about numerical expressions, where you all used germ DOS. So again, grouping, exponents, radical, multiplication, division, adding, and subtracting. So we looked at germ DOS, and we simplified things that had numbers only. So go ahead and jot that down in your notes that we already dealt with numerical. And in the numerical expressions, we were simplifying or evaluating. Again, these are going to be the words that you see for the directions in this unit. It'll say simplify, or it might say to evaluate. Now today, the big focus is actually going to be over here on algebraic expressions, because we're now bringing variables into the mix. So we're still going to be following the order of operations, but first we're actually going to take the variables in the problem and swap them out with the numbers, and then we're going to have GEMDAS, okay? So what makes an algebraic expression algebraic is the fact that there's numbers or letters. And again, you're still going to see the directions telling you to simplify or evaluate, okay? So when it says here to simplify the expression xy minus z, when x is a -3 and y is a -4 and z is a -2, I'm going to show you guys now how to actually plug these in. When you see two letters next to each other like that, y'all, it actually means to multiply. So when you see the x and the y like this, that means to take the -3 for x. The y is a -4. And then we're going to subtract z, which in this situation is a -2. Now what you guys are going to notice is that anywhere you see a letter over here, and I'm going to highlight it now, anywhere you see a letter, I plugged in the number in parentheses. Here was another letter, so I plugged the number in parentheses. Here was another letter, and I plugged its number in parentheses. And you still see that minus sign in between everything. Now the reason I need parentheses, y'all, is because if I don't, I could have a -3 and then this -4, and it looks like you would just subtract and tell me that that's a -7. And since we aren't subtracting here, we're supposed to be multiplying, that's why we need these parentheses. So we don't want to do this, we need the parentheses, and now we're able to follow germ DOS. So you're basically going to do that one extra step of plugging in, and now it looks like a numerical expression, and you already know what to do here. Anytime you see a negative times a negative, it's going to be a positive answer. And if you need your calculator there for that, that's okay. You've got a 3, make it negative. Do times 4, make it negative. And there's your positive 12. Now we already reviewed, and I can go back to it so that you guys can remember, we reviewed here what to do if you see a double negative. It turns into addition. So right here, this double negative is going to turn into a +2, which gives us a 14 overall for this final answer. So the first thing I wanted to show you guys was that anytime you plug in a number, you need parentheses. And if you're subtracting something that's negative, it will turn into addition. Now I'm actually going to use the same expression, xy minus z, and I'm going to change the numbers that we plug in. Okay, this time we're going to plug in a 5. Then we're going to plug in a -1, and now minus. And this time, z is just a straight up 2. So again, I think it's helpful to see it color-coded. I plugged in a number for x, then I plugged in times y, and then I hit minus, and then here's a z, okay, which is 2. So now when we follow the order of operations, this right here, 5 times -1 is -5 minus 2, and this is a -7. That's a -7 for that final answer. So feel free to use the calculator, like for this part. If you need to do the 5 times the 1 that's negative, there's your -5. Now you've just got -2, and there's the -7. Okay? So in this first question, what I showed you guys what to do if you see two letters next to each other, Down here, we're going to start to explore what happens if you see letters in the numerator and the denominator. And you can even see down here in this problem, there's a letter next to another letter with an exponent. So let's start over here. I'm going to start by taking A, which is a negative 16, in parentheses. We're going to add B, which is a negative 4, in parentheses. And then we're going to divide all of that by C, which is a 2, getting squared. So see how everything I plugged in is color-coded in parentheses? Now let's look at just the numerator. Since they're both negative, we're just going to same sign, add, and keep. So that's going to be a negative 20. Here, 2 squared is a 4. And here, the final answer would be a negative 5. If you're not comfortable with the negative divided by the positive, again, remember, as always, you have that calculator, the 20, just make it negative, divide by the 4, and boom, there's your final answer. Okay? All right, so now for this next one, we're going to plug in here. Let me get my colors out. We've got a negative 16. That's A. Then I have a minus sign. Then I have B, which is a negative 4. And all of that is now going to go over B, which is negative 4, times C squared. Now, C is the only thing getting squared here, so the 2 is what's going to be getting squared. So when we look at the numerator, remember, you've got a top part and a bottom part, and you can kind of just attack them both at the same time. So in the top part here, we just got to be really careful because we do have a double negative. So the top part is actually a negative 16 plus 4. I just want to point out that double negative. And then down here, since we're, rewriting it anyways, I might as well go ahead and take care of this and the fact that that 2 squared is a 4. And then I'm going to have a negative 4 times 4. So I've got a negative 4 and then times this 4. All right, so then back to the numerator. This right here, since I have different signs, I'm going to subtract and keep the sign of the bigger number. So 16, so it's negative. And then a negative times a positive here. This negative 4 times 4 is a negative 16. Now we've seen an example where when we divide here, it works out perfectly, like the negative 20 over 4 works out perfectly. And you might see problems like this, where it's not going to work out perfectly, but we can reduce. Now 4 is a number that goes into both of these. It goes into this 3 times, and it goes into this 4 times. And you guys also might remember from elementary that a negative divided by a negative is a positive. So this answer is actually a positive 3/4 or 0.75. And in case you don't believe me, let me just show you in the calculator real quick. When you do the 12 that's negative, and you divide by the 16 that's negative, there's the decimal, the 3/4 that we got. So that might happen sometimes this school year. You might get a fraction that you then just simply need to reduce. All right. So now let's take a look at some of these that have radicals in them. When you guys see a radical, you don't got to worry about the parentheses. You can just say, okay, the square root of x, if x is a 121, I can just do this. And then I'm going to put minus. And then I've got the square root of y, which is a 36. And then minus. And then z here is a negative 4. So I can't, let me make it negative. Almost forgot to make it negative. Negative 4, there we go. And I got to put the squared because it's z squared. So that's my top part. And all of that is going to be over z minus 7. Now when it's just something like this, again, I think it looks a little busy and crowded for the negative to be in parentheses. So down here, when you see just like a z minus 7, it's okay to just put negative 4 minus 7. It's really, the rule exists when the letters are next to each other and then for subtraction like this, because if you're subtracting a negative, you need to see the double negative. And if the letters are next to each other, you're multiplying and you need to be able to see that. Down here, when it's negative 4 minus 7, I feel like this, negative 4, parentheses, minus 7, it just looks really complicated unnecessarily, so we don't got to put it there. All right, so let's handle the numerator, okay? Since we have radicals and an exponent, I'm just going to go from left to right and say that the square root of 121 is an 11, and then I have my minus sign. Then I have the square root of 36 is a 6, and then I have my minus sign. And then right here, a negative 4 times a negative 4 is positive 16, so I'm just going to write a 16. I didn't put a negative in front of it. That's just still the minus sign from earlier. So there's the 16. All right, now down below, the negative 4 minus the 7, that's actually going to be, that's negative 11, same sign, add and keep. All right, so then we have 11 minus 6. 11 minus 6 is just 5. And now let's think about what 5 minus 16 would be. Again, if you want to use your calculator, so you don't have to worry about brain power, cool. 5 minus 16, that's a negative 11. And I'm going to just erase real quick. Let me just erase this from the previous answer so I have some room. All right, cool. So we said that the top part here was a negative 11. And the bottom part we already said was a negative 11. So anything divided by itself is always 1. And in case you need to see it in the calculator, the 11 that's negative, if I divide it by 11 that's negative, boom, there you go. It's a 1. So we've started to see one here with some radicals, if you will. These are radicals. And all that I'm doing here is changing a few things. Notice that the next problem has a plus sign here instead of a minus. So it actually isn't going to change too much. I'm still going to do the square root of 121 minus the square root of 36. And then just now it'll say plus, and then the negative 4 is still in parentheses getting squared. Now the bottom, literally nothing changes from one problem to the next. So I'm actually just going to copy down the answer that we have from the previous one. We already know that's supposed to be a negative 11 because it's negative 4 minus 7, and it's the same thing. So still here, this gets to be the 11, and then minus the 6. And here when you do a negative times a negative, it's a 16. So there's my 16. And then the plus sign that was in front of it from the problem is right there. And then all of this is now over negative 11. So when we do this, 11 minus 6, we still get a 5. But now 5 plus 16 in the numerator is a 21. So that could happen. And then you've got a 21 over a negative 11. This is already reduced. There's no number that will go into both of those. And let's just see in the calculator what happens. If I do a 21 that's and then divide it by the 11 that's negative. Yeah, see, that's a really weird decimal, so I would just probably leave that fraction there, okay? All right, and now last but not least on this page, same thing so far here and here, but you'll notice right here, I'm just simply going to plug in a positive 4 instead. So we still got the square root of 121. We have the square root of, oops, let me put the 121 back, minus the square root of 36, cool. Then you might see plus, and if you see a plus and it's a positive number, y'all, I wouldn't worry about the parentheses to make it look too confusing unnecessarily. And then down here, now it's a 4. Just be careful, it's a 4 minus 7. So let's see how that changes things. Up top, we still have 11, and then a minus. We have a 6, and then a plus, and then 4 squared was 16. And then the denominator this time, we have different signs, so we're going to subtract and keep the sign negative 3. Subtract and keep the sign of the bigger number. So if you do 11 minus 6, that's a 5. And then 5 plus 16 is a 21. We already had that answer from up above. And now we're going to divide that by a negative 3. So a 21 divided by a 3 that's negative is a negative 7. And that concludes the video on how to take values that are given to you and plug them in. We walked through several different types of problems. You guys are going to see there's a lot more things that I could throw your way, so just ask if there's anything you're unsure of, but that takes care of how to simplify or evaluate an algebraic expression if you know what to replace it with. Thank you for watching the video.